Hello, this is Miss Moore, and today during chemistry we're going to discuss scientific notation. Today's essential question: how do you convert from standard to scientific notation? Today's topic is really important. It's something you need to be very comfortable with. We're going to be using it a lot, and it's a little bit weird. All right, here we go. Scientific notation. We'll start with a quick discussion of why you might want to use scientific notation, and I'll give you a quick preview of what scientific notation looks like before we talk about how to actually convert numbers from standard to scientific notation. Okay, in science it's very common to work with very large and very small numbers. And I mean, there's going to be times when we're going to be using ridiculously large numbers and ridiculously small numbers, stuff with lots and lots of zeros either before or after the number. Okay, a couple quick examples. A drop of water contains approximately 170,000,000,000,000,000,000,000 molecules or particles. Cumbersome number? Yeah. Okay, I'll try to say this number. I think you say this as 17,000 quintillion molecules or particles. All right, how would you like to do a mathematical calculation with this number, putting all those zeros in the calculator? Would you feel confident that you put the right number of zeros in, thinking about for a test? Okay. Another example is the radius of a calcium atom. The radius of a calcium atom is 0.0000000000197. Again, another very cumbersome number. A number that would not be fun to be writing down, putting in a calculator, stuff like that. So, to make these numbers a little easier to work with, we can write them in something called scientific notation. Okay, so that's the reason we might want to use scientific notation. Let me next give you a preview of what scientific notation looks like. When a number is written in scientific notation, we take that number and we separate it into two different parts, with the first part being a number between 1 and 9. And the second part is what we call an exponent. All right, I'm going to give you an example of the same number written in both standard and scientific notation. So we're going to take, for example, this number 255,000,000. That's standard notation, regular writing. Okay, and I believe you say that number 25,500,000. That same number can be written in scientific notation, and it would be written as 2.55 times 10 to the 7th. This 2.55 is the first part, the number written between 1 and 9. This is the second part. It's the exponent. Okay, so once again, we've got the number between 1 and 9 and the exponent. And that's what scientific notation looks like. You ready to learn how to write numbers in scientific notation? Let's do it. Okay, what we're going to do is check out our number written in standard notation, right there. And we're going to rewrite the digits so that the number is between 1 and 9. Basically, we want a number that has only one digit before the decimal. And remember to keep the appropriate number of sig figs. So the first thing we should do is figure out the number of sig figs this number has. Okay, so 2, 5, and 5. Are those digits significant or not, and why? They are significant because all non-zero digits are significant. What about the zeros? Are they significant, and why? Are they between non-zero digits? No. Are they before or after a decimal? Well, there's no decimal written, so no, which means we have 3 sig figs. So we need to make sure we have 3 sig figs when we finish this. All right? Okay, so now we're going to take our number in standard notation and rewrite it so that the number is between 1 and 9. Basically, again, we want one digit before the decimal, which brings us to 2.55. We have one number before the decimal, the number's between 1 and 9, and it's 3 significant figures. Now, hopefully you guys note that 2.55 is completely not the same number as the number written in standard notation. So there's got to be another step here. The second part to writing a number in scientific notation is to write the exponent. So to do that, you count the number of times the decimal needed to be moved so that the number was between 1 and 9. And the number of times the decimal needs to be moved, that's going to be your exponent. Okay, so in step 1, we came up with the number 2.55. So to figure out the exponent, we need to count how many of the times the decimal needed to be moved from this number to get to that number. Okay, let's try that. First of all, I do not see a decimal in that number. So when you can't see a decimal, where is the implied decimal located? At the end. Whenever you don't see a decimal, it's implied that there's a decimal at the end of the number or to the right of the number. Okay, so how many times do we need to move the decimal to get from here to here? 1, 2, 3, 4, 5, 6, 7. We needed to move the decimal 7 times, and that 7 is going to be your exponent. All right, so now that we have an exponent, how do we write it in such a way that the person reading the number will know that you want to move the that 7 means move the decimal 7 times? Well, in math and in science, we have a symbol times 10. And I do realize that looks like multiply by 10. But what it means is, you got it, move the decimal. Okay? How many times do we want to move that decimal? We want to move it 7 times. So now, the number 255,000,000 is the same number as 2.55. Move the decimal 7 times. We've almost got scientific notation mastered. However, there's just one more little thing we need to think about. Remember that this means move the decimal 7 times. However, which direction are you supposed to move it in? If I just saw the number 2.55 times 10 to the 7th, or 2.55 move the decimal 7 times, 7 times which way? So that brings us to the exponent again and the sign of the exponent. The exponent will be positive if the original number was 1 or larger. The way I think about it is if it was a big number. If it's a big number, it's going to be a positive sign. And the exponent's going to be negative if the original number is less than 1 or it's a small number. I always think of, 0.00 or something. That's going to be a small number. So let me clean this up a little bit. This number here, is that a big number or a small number? It's a big number, which means the sign of the exponent is going to be positive. You don't actually have to write the positive sign. The positive sign is implied. Okay, let's try one more example. We have this number here, 0.0000000225. Let's write this in scientific notation. So what's the first thing we're supposed to do? We're supposed to write the number as a number between 1 and 9. Or you have 1 digit before the decimal. So with the appropriate number of sig figs. So how many sig figs do we have? Are any of these zeros significant? They're not, right? Because they're not between two non-zero digits, nor do they have a non-zero digit in front of them. So we only have 3 significant figures. So we're going to have 2.55. Now you'll notice that at this moment, this is the same number as the previous example. All right, so what are we supposed to do next? We're supposed to count how many times we had to move the decimal to get to that point. So we had to move it 1, 2, 3, 4, 5, 6, 7, 8. We had to move it 8 times. So 8 is going to be our exponent. How do we write move the decimal? Move the decimal. How many times? 8 times. Which direction? Is the number in standard notation a big number or a small number? Bigger than 1 or smaller than 1? It's a small number, which means it's negative. So in this case, our number in scientific notation is 2.55 times 10 to the negative 8. All right, it's time for a little independent practice on converting from standard to scientific notation. Go ahead and hit pause and try to write these two numbers in scientific notation. If you can't do it, first thing I'd like you to do is rewind, rewatch this, and see if you can figure it out. When you're ready, go ahead and hit play again, and I'll go through the answers with you. All right, so the first thing I'm going to do, if we're looking at number 1, is I'm going to determine the number of significant figures. And this number has 4 significant figures. These zeros are not significant because they are not between non-zero numbers, nor are they before or after a decimal. So, for step 1, I need to rewrite the number with only 1 digit in front of the decimal, so I'm going to have 3.102. All right. Now I got to figure out the exponent by figuring out how many times I had to move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. I had to move the decimal 9 times. And is this exponent going to be positive or negative? It's going to be positive because this number is larger than 1. Big numbers are positive. All right, so now my final answer is going to be 3.102. Move the decimal 9 times. Okay, and those two numbers are the same. One written in standard notation, one written in scientific notation. All right, let's try number 2. Again, I will start by figuring out the number of sig figs. None of these zeros here are significant because they're not between 2 non-zero digits, and while they are after a decimal, there's no non-zero digit before them. So I have these 6 here are significant. So I'll have 4.50062. And how many times did I have to move the decimal to get there? 1, 2, 3, 4, 5, 6, 7. I had to move the decimal 7 times. Now, is this exponent going to be positive or negative? This time it's going to be negative because this number here is a small number, right? It's less than 1. So my final answer is going to be 4.50062. Move the decimal negative 7 times. All right, there you go. You guys know how to write numbers in scientific notation. All right, let's quickly go over how to convert from scientific notation back to standard notation. If you're feeling okay with scientific notation, converting back to standard is not that big of a deal because it's applying the same things you just learned, just backwards. All right, so the big point of this is you need to use the sign of the exponent to determine which direction to move the decimal. That was the whole point of the positive and the negatives. All right, so a positive exponent means the number is bigger than 1, right? The number written in standard notation is bigger than 1, or it's a big number. All right, so let's try an example. We'll take 2.89 times 10 to the 4th. Okay, so let's go through and talk about what each one of these things mean. We know 2.89 means 2.89. That's easy. What does times 10 mean? It means move the decimal, right? And what does that 4 there mean? It means move the decimal 4 times. And because the exponent is positive, or the 4 is positive, we're going to move it 4 times to make a big number. Okay? So let's go back to our number, 2.89. What direction do we need to move the decimal to make that number look like a big number? We'd have to move it to the right. So, I'm running out of room here. I'll rewrite it down here. If I have 2.89, I need to move the decimal 4 times to the right to make it a big number. 1, 2, 3, 4. Okay. So I'll now rewrite our number 28900. 28900 is the standard form of the number 2.89 times 10 to the fourth. Okay, let's try another one. A negative exponent means what? The number is going to be a small number, right? It's less than 1. So, 6.21 times 10 to the negative third. All right, so once again, we know what 6.21 means. Times 10 again means move the decimal. And the 3 means we're going to move it 3 times. But this time, the exponent is negative, and a negative means we're going to be making a small number. All right, so let's go over to our number 6.21. What direction would you have to make to move the decimal to get 6.21 to be smaller than 1, or a small number? You'd have to move to the left. And we have to move to the left 3 times. 1, 2, 3. So our decimal is going to go there. Okay, so let's rewrite that. And by convention, you always put if there's a number that starts with a 0, you always put a 0 in front of the decimal. So you have 0.00621. And this number is the standard form of 6.21 times 10 to the negative third. All right, last thing for today. Go ahead and try on your own to take these numbers that are in scientific notation and turn them back into standard notation. So hit pause, do it on your own, review if you need to, and hit play when you're ready, and we'll go through it together. All right, so for number 1, this says 6.23. Move the decimal. Six times to make what kind of number? Big or small? A big number. Okay, so to make a big number, I'm going to have to move the decimal to the right. 6.23. 1, 2, 3, 4, 5, 6. Okay, so my final answer is 623. 1, 2, 3, 4. So that number there, 623, with 4 zeros after it, is the same number written in standard notation as 6.23 times 10 to the 6th written in scientific notation. Okay, let's try number 2. This says move the decimal 2 times to make a small number. So I have to move the decimal to the left to make the number smaller, and I have to move it 2 times. So 1, 2. Decimal goes there. So my final answer is going to be 0.0302. That is the standard form of 3.02 times 10 to the negative 2. And that's it for today. We'll do more practice on this tomorrow.